Alright, hello everyone, welcome back to another Math Your Day channel. So in today's video we'll be looking at branches, loops and nodes, right? So this is the easiest topic in electronics or electric engineering. I'm sorry about my voice. I'm caught up with a flu, right? So let's start with a branch first of all. Okay, so what is a branch? So a branch, or rather branches are like another name for circuit elements, right? So you could say it's another name for circuit elements. You could say a resistor, a battery, a capacitor, or an inductor, right? Or an inductor in that case, right? So it's another name for for a circuit element. A circuit element is basically what creates a circuit in that case, right? Without elements, then we do not have a circuit, right? So like we could say, well, if we have an inductor, a capacitor, and then a resistor, right? So these are what we call branches, right? So here, this is an inductor, this is a capacitor, and this is a resistor, this is a voltage source, right? So this here is a branch, this here is a branch, this here is a branch, and the voltage source is also a branch, right? So if they ask how many branches are in the circuit element, you can see that you have 1, 2, 3, and then 4. So meaning we have 4 branches overall, right? So branch is basically another name for circuit elements. Circuit element is basically what makes a circuit, right? What creates a circuit, like a resistor, capacitor, an inductor, a voltage source, right? So make sure that you understand what a branch is, right? And then if we talk about nodes, so basically node is a junction of connecting wires, right? A junction of connecting wires. So if I can remove uh okay, just do this. uh okay, there you go. So a node is basically a junction of connecting wires. Now every point on a node is at the same potential, which means that same voltage, right? So in this case you can see that this point here is what we call a node. So basically a node is a 2 points, rather a point. In this case, by saying 2 points, I mean that if we say there are 2 points, it means that we have a branch. If like we have a branch like this, in this case we have this inductor here. So in this case it means that we have two nodes, right? We have a node here, and also we have a node here in that case, right? Here also have a node, and here also have this common node here. We also have this common node here, right? So make sure that you know what a node is basically. So when there is no element or a branch, then we consider that as one complete node, right? Because the voltage at this point here is also the voltage at this point here, because there is no voltage drop, right? So meaning these 2 points are the same, so hence why we say it's basically one node, because we said every point on a node is at the same potential, right? So here, this point here, this VA is not equal to this VC here, so we can't consider these two the same, right? We can't consider these two the same because the voltage there is not the same as the voltage in this case here, uh, in this point, at this point here, right? Or rather, let me put resistance. Yeah, there you go. Resistor, then the resistor here. Okay, so that is what we call a node, right? So when there's a branch, then we have two nodes, right? Like in this point here, we have this one resistor, we have this resistor here, and hence we have two nodes. And then here we have a node. Here we also have this common node here. So make sure that you understand what a node is, right? And then moving on to a loop, right? So loops. So a closed path that begins and ends at the same node is called a loop. So what I mean that, okay, so if we have a circuit, right? Let's say you have uh, a resistor there, then a voltage source, and the resistance, okay? So you have another resistance there. Let's see. Okay, so here in this case, I have, if you notice something here, this here is my branch, right? Remember we said branch is a branch is a circuit element, right? So this is a circuit element, hence is a branch. This here is a branch, this here is a branch, and also this point here is a branch, right? Okay, let's now identify our nodes. This point here is one node, here another node, here another node, and we notice that at this point here there's no circuit element or a branch, so meaning this is one common node right there. So meaning we have how many branches? We have 1, 2, 3, 4, 5 branches. Let's say 5 B's, and then we have 1, 2, 3, 4 loops. In that case, we have 4 loops. Not four nodes, not loops, sorry. And then what's a loop? A loop is basically a closed path that begins and ends at the same node, right? So uh, in this case here, I can remove this here. Just remove this point here. Okay, so in this case here, you can see that it's a closed path, right, that begins and ends at the same node. You can see that this point here is a closed path. This point here is closed, right? It's a path that is closed, or rather a closed path. So meaning this is a loop here, right? Notice that this here is a loop. This here again is a closed path. It begins and end at the same node, right? So this here again, we have a loop, and basically we have this one big loop here. We have this one big loop that is there, right? So here we have 3 loops in that case, right? So we have 5 branches. We have five. No, how many? We have one. We have 4 nodes, and then we have 3 loops, right? We have 3 loops, and then there's what we call an independent loop, right? So an independent loop is basically a loop that contains at least one element that is not part of any other loops, or rather that is not part of any other loops in that case, right? So let us see here in this case. So you can see that it is an independent loop that at least contains one circuit element. So you can see here we do have this element here, so meaning this point here is a loop. So we have one independent loop here. Again here, this is a what? This is another loop in that case. But we can't consider this whole thing as an independent loop, because now it is no longer independent, right? Because which is say that it is not part of any other loops, right? You can see that here it is independent, right? It's the only loop in that case, right? It is independent of any other loops, right? And then loop 2 again is independent. So if you say this whole thing is an independent loop, then we are wrong, because if you say this whole thing is an independent loop, that means that, but we do have 2 loops. That means that loop, rather that whole loop there, it's dependent, or rather depends on these two loops. In that case, it's no longer independent. So hence why we said an independent loop is not part of any other loops in that case, right? So that whole part, or rather this whole circuit here, or rather circuit, is not an independent loop, but this section here is an independent loop, and this section is an independent loop too. So meaning I have two independent loops. Okay, so now uh, a, um, a formula, rather a formula to check whether we are in the correct path or not, is given as branch is equal to a node plus a loop minus 1, right? This formula here is important. Please take note of this formula here, right? So how many branches we have? We have 5 branches. Node, we have 4 nodes. We have 2, right? We have 2 loops and minus 1, right? Here we have 2 minus 1 is 1, 1 plus 4 is 5. So meaning the left hand side is equal to the right hand side. So meaning that in that case is correct, right? Let's look at another one, an example here. Let's say we have a circuit. Um, we have a resistance, another say a resistor, one resistor there, another resistance, a resistor there. Okay, so how many how many branches how many branches, loops, independent loops, and nodes uh, in the following circuit, right? So the question reads, how many branches, loops, or independent loops and nodes are in this circuit here, right? So pause the video if you want to check whether you are in the correct path, or rather you understand what we have done, right? So in this case here, right, let's start with branches. So you notice that the branch is a circuit element, and hence we have this circuit element here, we have this circuit element here, we have this one here, we have this one here, this uh and that, right? So you have 1 2 3 4 5 6 7 8, right? So meaning I have 8 branches. Okay, we have 8 uh branches. Just gonna say b is equal to 8. Okay, so now let us look at how many loops in this. Notice how I say loops and not independent loops. Loops, right? So we have a loop here, 1 2 3. We have this loop here, 4. Then we have this loop here, 5, right? As well as this whole loop in that case, meaning I have how many loops? You have 6 loops with a capital letter L. We have 6 loops, and then our independent loops, we have 1 2 3 independent loops. So our independent loops, we have 3. Then our nodes, how many nodes do we have? Let us count. We have 1. Let me use another color there. Okay, we have 1, 2, 3. Remember, when there's no branch, or rather an element, then it is considered to be one common node right there, right? So you have 1, 2, 3, 4, 5, 6 nodes, right? So my n in that case is 6. Now let us confirm using our formula, right? Given as b is equal to n plus independent loop minus 1. So my b is 8, right? Which is equal to n 6 plus 3 minus 1. So 3 minus 1 is 2, 6 plus 2 is 8. So in that case, this is correct, right? So by the way, this formula here is also known as the theorem of network topology, right? So if you're interested, this is the theorem of network topology. This is just to confirm um, this is just to confirm whether your answer um, is correct or not, right? So to confirm, the left hand side should be exactly the same as the right hand side, uh, for you to know whether you are in a correct path, right? So that's it for this one. So the next time we will be looking at Kirchhoff's law, and of course voltage division and current division, right? So that's it. I hope that you understand this topic here. It's a very easy topic, and yeah, practice more of this. I will look at more past papers, um, and yeah, that's about it. Thank you for watching. I'll catch you later. You